Okay, we've already done an introduction into solving basic trig equations, and so we've already talked about asking yourself the question, what angle or angles have this particular trig value? But everything that you've done so far has been given a domain restriction. We've told you to only solve the equation between 0 and 360, or we've told you to answer between 0 and 2 pi, or something like that. So we've told you where to look, what direction to rotate in to look, how many answers to look for. All of that is summed up in those domain restrictions. What we have not dealt with enough is the general solutions, and we need to deal with that more because that's going to happen quite a bit. So when you're asked to solve a trig equation and you're not told where to look for your answers, you have to look for all answers. And that means we've got to write our answers as a general solution. So for example, this first equation says sine of theta is equal to 1. The equation is already solved for you. We just need to take the next step and rearrange that equation. Now remember what we're doing. Technically, even though we don't actually show it very often, is we're taking the inverse sine of both sides, because remember, inverses cancel each other out, so inverse sine and sine will cancel each other out, and theta would be by itself. And so really what we're evaluating is the inverse sine of 1. And what that equation is asking you, remember what I told you guys to phrase it as a question, is it's saying what angles have a sine value of 1. And remember that on your unit circle, the sine value is the y-coordinate. So I'm asking you what angles have a y-coordinate of 1 on your unit circle. Okay, well, if you think about your unit circle, there's only one place that happens. That's the first case, is that the answer you're going to get only occurs in one place on your unit circle. And the one place it occurs on your unit circle is up at 90 degrees, or pi halves. So that means that pi halves, or 90 degrees, is your answer. The problem is that that's your primary answer, just one trip around your unit circle, but I didn't tell you up here in the original equation that you were only solving between 0 and 360, or between 0 and 2 pi. I want the list of all of the answers. And remember that any other answer that I have has got to be an angle that ends up in the same place as this one. And so that means that I simply need to write it as a coterminal angle. That's what general solutions mean, is generate the list of angles that would also give me answers. And there's only one location on the unit circle that I would have the correct answer. So to write it as a coterminal angle, in degrees, remember we always wrote plus or minus 360 n. And in radians, that would be 2 pi n. And that simply means that we can keep coming back around one complete circle over and over and over again. Start here, come back around, come back around, come back around, and I keep landing in the same place and having a sine value of 1. Now we've always, so far, been calling this the inverse sine relation, and there's a reason it's a relation. We're going to get into that next week. But there is another name for it. They go by two different names. And that other name is arc sine. So what that means is that these are interchangeable. So saying inverse sine of 1 is the same thing as saying arc sine of 1. And I don't have a lot of room to write that, so I'm going to jump up here really quick. So inverse sine of 1 is the same thing as arc sine of 1. And different textbooks teach it different ways about, do they exactly mean the same thing, or how do you differentiate between the two? Like I said, we're going to get into that next week. Okay, and remember, from these notes from before, this is not the same thing as the reciprocal function. So be careful about where that -1 appears. The second situation you're going to run into is when your answers occur at more than one location on the unit circle and the answers are equally spaced from each other. For example, if I asked you where on your unit circle cosine of theta was equal to 0, and remember cosine is your x-coordinate, well, there's two places on your unit circle that have an x-coordinate of 0, here and here. And they're 180 degrees apart from each other. So if I start at either one of them, if I started up here, I would only have to go 180 to get to the next angle that's an answer. And then from here, I would only have to go another 180. And so that's the second situation, is that you've got more than one location on your unit circle, and they're equally spaced from each other. So the second example says solve tangent of theta is equal to 1. And please make sure you note that. If you have yet to fill in your tangent values on your unit circle, it would be a very good idea to do it. And so remember, I told you guys the first few days of this unit I'm going to show this step, even though you're not required to. I'm going to show that what we're doing is taking the inverse tangent of both sides, so that we're canceling out tangent on the left side or peeling it away. And so what we're solving is inverse tangent of 1. And just like inverse sine can also be called arcsine, inverse tangent can also be called arctangent. Okay, so they're interchangeable. And so I'm asking you what angles on your unit circle have a tangent value of 1. And the two places on your unit circle where that happens are up here at 45 degrees and down here at 225 degrees. And so if I started at either one of those locations, let's say that I started up here at this location, how far would I have to go to swing around to that location? Hopefully you were thinking or said 180 degrees. So from here, I would have to swing another 180 to get back to there. So what we can do is we can write one pattern. We can say, we can start at either one, but of course usually people start at this location right here. So we can say if we start at 45 degrees, then if I start going 180 degrees in any direction, then I just keep cycling around to one of the two angles that has the correct tangent value. And of course, since we weren't told to solve in degrees or radians, we'd want to write both. We don't require that you guys write both. If we don't tell you what units to answer in, most of you, of course, are going to choose to answer in degrees, but your quiz next week is going to be in radians, so it's still very good practice. So 45 degrees in radians is just pi fourths. And then to go 180 degrees in any direction would just be pi. Okay, so that's the second situation. The third situation is when your numbers occur more than once in a unit circle, but they're not equally spaced. So you can't just start at one location and start stepping 180 and then 180 and then 180 and then 180. You're going to have to list your answers as two separate solutions. So if sine of theta is square root of 3 over 2, and remember that we're going to take the inverse sine of both sides to get rid of sine on the left. And so that gets rid of sine over there. And so our rearranged equation says that theta is equal to inverse sine of square root of 3 over 2, which is also the same thing as arcsine of square root of 3 over 2. And then we got to figure out where are the angle or angles that have that sine value. So once again, if we think back to our unit circle, the first place that happens is up here at 60, and the second place that happens is over here at 120. Okay, but there's a problem with that. If I start at 60, start here, how far do I need to swing around to get to the second answer? Right? Just 60 degrees, right? But if I swing around another 60, am I at another angle that has the same sine value? No, I'm not. And so I can't just start here and add 60 and then add another 60 and then add another 60. So since I can't take equal steps and keep landing on angles that have the right answer, I have to list them as two separate answers. So that means that I list the first answer, which was up here at 60 degrees, and I list the second answer, which was over at 120 degrees. And then to get to either one of those locations over and over and over again, I could start here at 60. I have to go 360 to come all the way back around to it. So I would write it as a coterminal angle, or a general solution, so plus or minus 360n. And then the same thing would have to happen over here. In order to get back to right there, I have to go all the way around 360. So plus or minus 360n. And then, of course, the radian equivalents to those would say that instead of starting at 60, we would have started at pi thirds. And instead of going 360 degrees to come back around to that angle, we would have gone to pi. And then instead of 120 degrees, we would have gone 2 pi thirds. And then the same thing. Instead of going 360, we would have gone 2 pi. Okay, this is the most common situation because most of your unit circle equations are sine and cosine equations. Tangent is always going to be equally spaced, so tangent and cotangent are always going to be case 2. But most of the time, our other equations are into case 3. Sine of square root of 2 over 2, cosine is 1/2, things like that. Those are not equally spaced from each other. So most of your solutions come from case 3. Case 4 is coming up, but before we do that, I want you guys to pause it, and I want you to try one of these for yourselves finally. So solve, this is still in case 3. I want you to solve and figure out where cosine is negative square root of 2 over 2. Okay, so those are the two angles you should have located. This angle over here is 3 pi fourths. And then the other one is over here, because I'm asking you where is your x coordinate equal to negative square root of 2 over 2. And those are the two locations on your unit circle. And they're not equally spaced because I can't just start here and rotate 90 and then keep rotating 90 and getting around to answers. That won't work. So I write them each separately and write them as their own general solution. Okay, and then of course you could answer in degrees if you want to. One of the things you could do is, because there were no domain restrictions at all, you could have also written this answer in a second format. From here around is positive 3 pi fourths. From here to here is negative 3 pi fourths. So you could have written it, and that is one thing, I don't know if you guys remember, but we talked about how cosine is symmetric. So if 3 pi fourths is an answer, so is negative 3 pi fourths. And we're going to talk a lot more about that in the coming weeks, because we're going to see a lot of these. We're going to be solving equations for several weeks still. The final situation is one where your answers aren't on your unit circle. So these are the picture drawing problems. You guys remember those from the first trig unit, where I told you where to draw your triangle, and I told you some of the information about that triangle, and you found the other trig values for that triangle. And so what you have to figure out is, where would this picture be located? So if I look at this fifth example, it says sine of theta is negative 1/3. Okay, remember sine is the y coordinate of something. And so if that's a negative number, that means that my picture is in one of two places. The only two places where sine is negative would be down here or down here. And we don't know which answer it is because we weren't told any domain restrictions. We weren't told it has to be in quadrant 4 or something like that. So we have to solve for both of them. So what we do is, depending on what unit we want to answer in, we put ourselves in that mode in our calculator. These have to be a calculator kind of problem. And so I'm going to do inverse sine of negative 1/3 in my calculator. And when I do inverse sine of negative 1/3 in my calculator in degree mode, so make sure you're in degree mode, the answer that I'm going to get is negative 19.47 degrees. So that's telling me to start here at 0 and rotate down 19.47 degrees. So that angle right there is 19.47 degrees in size. Okay? Well, remember, trig is all based off of reference angles. So if this angle is 19.47 degrees and it's got the correct sine value, then okay. So cosine is positive in quadrant 1 and quadrant 4. So that means you have answers in one of those two places. So you put your calculator in degree mode and you do inverse cosine of 1/4. And the answer that your calculator is going to give you for this angle right there is it's going to give you 75.52 degrees. Okay, and don't forget to leave room. We're going to do this exact same process in radians. So if this one is 75.52 degrees, then so is the size of this one. We would just have to start at 0 and rotate down 75.52 degrees. And so that means your other answer is negative 75.52 degrees. It's another good example of how cosine is symmetric. If 75.52 is an answer, automatically so is negative 75.52. Okay, so we've got our two answers. They're not equally spaced, so I have to write them separately. And to put them both as general solutions, I simply write plus or minus 360n. Okay? If I want to repeat that whole process, all I have to do is hit the mode button on my calculator and put it in radian mode. And then I type in the same thing again, inverse cosine of 1/4. And so the answer that I get, which is still 75.52 degrees, we're just measuring in radians, is 1.32 radians. And then to write it as a general solution, you wouldn't put plus or minus 360n, you would put plus or minus 2 pi n. But since cosine is still symmetric, if 1.32 radians is an answer, so is negative 1.32 radians. And then the general solution would be plus or minus 2 pi n. Okay? Now remember, this is only important, or this is all of these steps, the general solutions, the different cases you could run into, are only important when you have no domain restrictions. Now, one thing you do need to be prepared for is that at some point, very soon, I'm going to start giving you domain restrictions that say solve from negative 180 degrees to positive 540 degrees. So it's really a safe idea to always start out as a general solution, and then you can simply generate the list of answers that would fit within whatever your domain restriction is. So starting out as a general solution all the time means that sometimes you can stop. because you won't be given a domain restriction. And sometimes you would use that general solution to generate your answers. And also, of course, keep in mind that when you're solving equations, if you get something that says cosine of theta is equal to 3, it's automatically no solution, because sine and cosine only go up and down between -1 and 1. Now, your other trig functions, you can solve equations that say tangent of theta is equal to 3. That's not a problem. But you can't have an equation that says cosine or sine is equal to 3, because they never get that big. Okay? So we're going to spend the next, week practicing inverse trig and solving equations, because there's lots of different variations and there's lots of different difficulty levels, and we're going to need lots of practice with it. So it's okay if you have questions now. We're going to be helping you in class Friday, Monday, Tuesday, all of next week. Okay? Thanks.